Hello everyone, welcome to the second part of lecture series of numerical matrix methods for solving the system of linear equations. For simplicity, I'm going to consider the system of three equations in three unknowns, but please note that the similar kind of method or the approach can be applied to n cross n matrix, n cross n system too. So here I have written the linear system of equations in a compact matrix form, that is Ax equal to B. So let us see how does the Crouts method work. So what we do is we are going to write A as the product of an upper and lower triangular matrices. So let us see what are they. So I write A as Lu, and L is written as L1100, L21, L220, etc., and U as 1, U12, U13, etc. So now what we do is, let us see what is the next step for solving the system using the Crouts method. Okay, since we have written A as a product of lower triangular and upper triangular matrix, Lu, what we are going to do is we are going to substitute this Lu in this equation Ax equal to B. So what we get? We get Lux equal to B. So next what I'm going to do is that I'm going to write this Ux as some unknown um, column matrix, say Y. So our task is to find this Y. So therefore what we can do is when I substitute this Y back to this equation number 2, what I'm going to get is I'm going to get this equation number 4, that is Ly equal to B. Now here B will be a known matrix because we get from this equation. Now L will be also known. How it is known, that we are going to cover later. So here L and B both will be known. Using this information we can calculate this unknown value of Y, and then we are going to substitute back this value of Y in this equation. So therefore what we have here is, now again U will be known. We'll know how this U is known, and also Y we have calculated from equation number 4. So using the value of U and using the value of Y, I'm going to calculate the value of X. So how to do this? For that I'm going to give you an algorithm. So if you follow the algorithm, we will be able to solve any system of linear algebraic equations using the Crouts method. Okay, so how does this algorithm works? So step 1, we write A equal to product of Lu. So we are actually going to write what is L and what is U, and then we are going to perform the matrix multiplication. So when we do that, we get this RHS as nothing but the product of these two matrices L and U. So and to LHS, what I have written is, I have written A in expansion form, expanded form. So A is A11, A12 and A13, etc. Since I have written this matrix, this matrix is equal to this matrix, it means that I am saying that A is equal to L times U, and therefore by the equality I am going to get that A11 must be equal to L11, A12 must be equal to L11 into U12, and so on. For example, I can also write that A32 is equal to L31 times U12 plus L32. So what am I going to do with this equality? When I equate this respect to the corresponding elements of these two matrices, what I'm going to get is, for example, if I equate the elements of first row, what I'm going to get? I'm going to get A11 equal to L11. So what happens is, since A11 is a known value, you get the value for L11 which is unknown. Okay. So once I do that, I can go to the next equation. And what is the next equation? I'm going to get A1. I'm going to equate the corresponding elements of the matrices. So I get A12 equal to L11 times U12. So here L11 is also calculated in the previous step, and A12 is known. So therefore we can calculate U12. So U12 is going to be A12 by L11. So in a similar way, we can keep on equating this equalities, and then we are going to finally get the values of L11, L21, L22, etc. Similarly, U12, U13, and U23. That means once we get this value, we are going to plug this value back onto these matrices. So we can write actual values of L and U. So we can write actual matrices, what is L and what is U. Okay, so step 3 is to write L and U. So in the previous step, you have calculated the entries of the matrix L and U. So we are going to write now what is L and what is U. Then the step number 4 is we are going to solve this equation. So as I told you earlier, since we have obtained the value of L here, we can use this value of L in this equation, and B is already known from the equation of the system. So what we do is, when we solve this using forward substitution, we are going to get the value of y. What do you mean by forward substitution? That you will understand when we are going to solve the example. So once we get value of y, then we go to the last step. What is the last step? You solve now the equation, because if you remember, we had taken ux equal to y. Now since we have calculated y in this previous step, so y is going to be known, and from the step 3 we can get the value of u. So here u and y are known values, so therefore finally we can find the solution matrix, that is x, which is an unknown value, using the backward substitution. Okay, so what is the backward substitution? Again, that I'm going to explain when I'm going to solve the example. That will be in the next video lecture. Okay, so what we do is, now I'm giving you this Moodle login. Uh, this is the user ID and this is the password, and this is the site where you can log in. This site will have a lot of practice questions, quizzes, and more resources available. What you can do is, you can pause this video and maybe you can take one example from the question bank that I've given on this Moodle site, and solve that example using the Crouts method that I have explained. But before that, if you want, you can wait for the next video and understand how exactly the example is being solved, and after that you can try practicing more such examples. One last thing is that you can check whether your answer is correct or wrong, because there will be Scilab codes available on this Moodle site. So you can use those Scilab codes, enter the values of the matrix in the Scilab code, and check whether the answer that you have obtained by manually solving the example with the Scilab code. Okay, that's all for today. Let us see how to solve the example using Crouts method in the next video. Thank you. Thanks a lot.